In this tutorial, you will learn how to create a basic web application with FoalTS. The demo application is a simple to-do list with which users can view, create, and delete their tasks. Let's open a new terminal. First, you need to install globally the command line interface, or CLI, of FoalTS. It will help you create a new project and generate files all along your development. Then you can create a new application with the create-app command. This command generates a new directory with the basic structure of the new application. It also installs all the dependencies. Let's open the project in Visual Studio Code and look at what create-app created. The outer My App directory is just a container for your project. The config directory contains configuration files for your different environments: production, test, development. The Node modules directory contains all the prod and dev dependencies of your project. The static files are located in the public directory. They are usually images, CSS, and client JavaScript files, and are served directly when the server is running. The most important directory of your project is the source directory, which contains all the source code of the application: controllers, services, hooks, tests, and scripts. The language that is used to develop a FoalTS application is TypeScript. It is a typed superset of JavaScript that compiles to plain JavaScript. The benefits of using TypeScript are many, but in summary, the language provides great tools and the features of JavaScript. Now let's verify that the FoalTS project works. Open a new terminal and run the following commands. npm run develop. You've started the development server. The development server watches at your files and automatically compiles and reloads your code. You don't need to restart the server each time you make code changes. Note that this is only intended to be used in development, so don't use it in production. If you now go to your browser and go to the localhost address, you should now see the text "Welcome on board." Congratulations, you now have a server running. The application that you will create is a simple to-do list. It consists of a front-end part that has already been written for you and a back-end part that will be the topic of this tutorial. First, you need to download the HTML, CSS, and JS files from the official FoalTS website. Next, you are going to unzip the files and put all the .lead files in the static directory public. The code executed in the browser will make API calls to the server to view, create, and delete their task. If you now go to the browser and refresh the page, you should now see this. As you haven't yet implemented the server API, the frontend gets an error when fetching the to-dos. It is displayed at the bottom of the page. If you try to type something in the text input and press enter to create a new task, you'll get an error as well. Let's see the detail of the API we want to build. We want to add 3 routes to list, create, and delete tasks. Alright, let's create your first model. The CLI provides a useful command to generate a new file with an empty model. For generate entity to do. FoalTS uses TypeORM, a complete object relational mapper, to communicate with the database. In TypeORM, simple models are called entities and are classes decorated with the entity decorator. Every new project in FoalTS uses an SQLite database, as it doesn't require any additional installation. but TypeORM supports many other databases. We'll keep this one in this tutorial for simplicity. Open the file todo.entity.ts in the entities directory and add a text column. This class is a representation of the SQL table Todo. Currently, this table does not exist in the database. You have to create it. You can do this manually using database software, for example, or use migrations, a programmatic way to update a database schema. The advantage of using migrations is that you can create, update, and delete your tables directly from the definition of your entities. They also ensure that all your environments, prod, dev, test, and co-developers have the same table definitions. Let's see how to use them. First, run the following command to generate your migration file. TypeORM will compare your current database schema with the definition of your entities and generate the appropriate SQL queries. A new file appears in the migration directories. Let's open it. The up method contains all the SQL queries that will be executed during the migration. Let's run the migration. TypeORM examines all the migrations that have been run previously, none in this case, and execute the new ones. Your database, db.sqli3, now contains a new table named Todo. Now it's time to populate the database with some tasks. You could run the command line interface of your database, in that case SQLite, and enter some SQL queries. But this is risky and not very handy. It becomes especially true when the complexity of your models increase. That's why you are going to create and use a shell script instead. Let's run the generate command for generate script create-todo. A shell script is a piece of code intended to be called from the command line. It has access to all the components of your application, including your models. A shell script is divided in two parts. A schema object, which defines the specification of the command line's arguments, and a main function, which gets these arguments as an object and executes some code. Open the new generate file in the scripts directory and update its content. We're going to modify the schema object. We create a new task with the text given in the command line. And then we save the task in the database and then display it in the console. Finally, whatever happens, we close the connection to the database. Now let's build the script. And then you are going to run the script to create task in the database. Note that if you try to create a new to-do without specifying the text argument, you'll get the error below. Good! So far you have a frontend working properly and some to-dos in your database. Now it's time to code a REST API to link them both. To do so, you are going to use a controller. Controllers receive the HTTP request and process them. They may call services in the background to help them do this. We will not study the services in this tutorial. Open the file api.controller.ts in the controllers directory and replace its content. Controllers have special methods that define the routes and the respective handlers. These functions are decorated by one of the decorators get, post, patch, put, or delete, which define the HTTP method and the path of the route. In this case, the controller responds with a 200 status and a mock data, two fake to-dos. Refresh your browser, you should see the two to-dos printed. Now, we would like to return the to-dos stored in the database. Update the code as follows. If you refresh your browser, you should now see the task that we created through the command line. Now you can add the create feature. Let's create a new post to-do method. We first create a new to-do with the body of the HTTP request. Then we save the to-do in the database. And finally, we return the new to-do with the ID generated by the database. The status is 201. Now we can add the delete feature with the delete to-do method. First, we get the to-do with the ID given in the URL if it exists. We return a 404 not found response if no such to-do exists. We remove the to-do from the database. And then we return a successful empty response if everything is okay. The status is 204. The context object, which is passed to each route handler, contains the express request object. This represents the HTTP request and has properties for the request query string, parameters, body, HTTP headers, and so on. Now, type a new to-do in the input text and press enter. The task appears in the to-do list. If you click on the checkbox, the to-do is successfully deleted. Refresh the page, it should still be there. The last thing to know is how the API controller is bound to the request handler. You defined so far routes in the controller, but never registered the controller anywhere. This is done in the app.controller.ts file, the entry point of your application. Open the file app.controller.ts. This controller is the main controller of the application. It is directly called when a request comes in. It may have subcontrollers that go in the controller's directory. Alright, currently inputs received by the server are not checked. Everyone could send anything when requesting post/API/to-dos. That's why client inputs cannot be trusted. You will use the validate body and validate path param hooks to validate and sanitize incoming data. A hook is a decorator that is attached to a route handler, a controller method. It is executed before the method and is therefore particularly suitable for validation or access control. The validate body and validate path param check respectively the body and parent properties of the request object. They take a schema as unique argument. FoalTS uses AJV, a fast JSON schema validator, to define its schemas. Let's add validation and sanitation to your application. In fact, you have already defined the to-do schema in the create-todo script earlier. At the top of the post-to-do method, you are going to add the validate body hook. This schema defines that we expect an object with a property text, which is a string and which is recurrent. And we say that we do not expect additional properties. Then we can add a validation to our delete feature. Here we're going to say that the ID, which is passed in the URL, is a number. And if we receive something that is not a number, the hook will return a 400 bad request error. Now, if we open Postman to test our API, we are going to see that validation works. Alright, so this is the end of this tutorial. I hope it helped you understand how to use FoalTS. And if you have any questions, feel free to leave a comment below the video or in our Discord channel.